I woke up with a couple of ideas, or had a couple of ideas after I woke up, so I'm taking the time to document at least one of them. This idea is called conscious UI, or UI that's sentient, aware. UI stands for user interface, so it is the mechanism to which we would interface with some kind of a computational device, whether it's your smartphone, your computer, your toaster, microwave, what have you. So what I was thinking was like, and I made a blog post about or another video about the four areas of computing, or the four areas that I believe will revolutionize the way computing is done in the foreseeable future, perhaps within the decade. So within the next 10 years, a lot of changes will happen, and the changes will come much more rapidly. So, but this idea is about user interface again that's aware of its surroundings, and it is not just aware; it directly has a link to the user's cognition. And what I mean by this is, so let's take a look at the UIs as they exist today. The user interfaces today, I believe, are super inefficient. It's predicated on the designs that were largely pioneered in the 60s with Douglas Engelbart, and those designs have stuck with us. So I've actually not just made the video, I've blogged about this, I've thought about this just a bit. But so skipping to the idea, what I was thinking was, what if the UI was sentient, aware, and it had the contextual awareness of what the user not just wanted, but it could actually predict what the user would do next. So that's like the ideal mechanism by which it kind of defined the what. The how, I was thinking, would be predicated upon not just sensing the actual presence of a button being invoked or a menu being invoked, but actually being able to ascertain the how. What is it exactly that the user wanted to do, so that the construct could just deduce that and make it go. So eliminate this altogether, perhaps even eliminate this and this. So no touch, no sight, and no audio. So then, and no voice. So then the question is, how would that work? It's a good question. So I'm a big fan of advances, and not a big fan, but I think the prospects of using brain-machine interfaces could truly revolutionize computing in certain domains. I don't know how long it's going to take for it to go mainstream. Right now it seems to be going mainstream for meditation and certain applications for individuals with disabilities or who are immobile. At least that's my perception. It could be used for different things as well, especially with some of these areas going more mainstream and opening up their SDKs. But going back to the example, what I was thinking was, I've looked at some of the technology that could make this happen, but really the user interface, if it becomes aware, then we could have a direct coupling or direct link to the actual computational device, as opposed to using Neanderthal mechanisms in order to be able to get computing to work. And I blogged about this a couple of years ago, where I said the user interface actually inhibits the true means, mechanisms by which we can uh, um, make use of computational resources, and the design inhibits uh, like using computation at a speed and a capacity at which it can truly be powered today. So, in short, it's my sense that the UI is the inhibitor, and we largely kind of get over this problem with automation in general, whereby we cluster problems into constituent boxes and then use computation as a mechanism in order to be able to get over those problems. So we define the problem, a solution is created, and then that solution is put in place in order to be able to overcome or address that problem. And many such facets exist across the construct by which computation is leveraged. But what I'm thinking is it means to be able to leverage computation on a real-time basis in order to be able to deliver any solution and as you deem fit. So it could be not just used for regular day-to-day computational needs, but also for some of their other wider, bigger challenges, problems, and solutions could be developed almost on a real-time basis. So I'm thinking of a couple of examples. I don't know how this is going to be accomplished again, but we've got a couple of ideas. But so imagine you wake up in the morning and right now, even if you didn't want to touch your phone or any computing device at that, thanks. So even if you didn't want to do that, then you'd have the ability to be able to just kind of talk. Amazon's got this product where you can just give voice commands. I think Google's got one out too. There could be others. But what if you could just, instead of like telling the construct, giving it commands to do something, what if you could just think about it and the means by which you'd interact with the computational device would just be able to read that thought and execute about it. So there was kind of like, this is how you start at least. So instead of actually monitoring, perhaps measuring all the thoughts on a real-time basis and be able to like categorize that, it's difficult. So instead, what you do is you look at specific thought patterns, and how you do that is it could be like super simple. You can run the tests in super simple ways by which when you think of something, then something happens. And there could be menus invoked in specific parts of the application in order to be able to do something, again, when something is taught about. So in this case, what would happen is, say I wanted to play a certain playlist in an application or on Spotify. So there will be some marker for that, which the construct is going to be able to pick that up from my cognition or my sentient awareness. And it would just play. It would just, the construct would just start playing it. And then I would, at the same time, I could just give quick commands in succession by just thinking about them. So I'll do that, and I'll also say, well, bring the weather, or show the sports scores, and do that in either do that simultaneously or do that one after the other. So it could be like another marker for that. Like, I could just think of the letter S, or uh, you know, the letter C for concurrent, something like that. I don't know. I would give this a lot of thought and think about this idea in that much detail in the morning. And then that's the input, the output. I was just thinking this. So the question is, how exactly is this going to be modeled? And so, sorry, there's a little noise here. So the question is, like, how do you do that? And I don't think it's conceivable for individuals to be walking around with brain-machine interfaces on their skull cap every morning. At the same time, I was thinking that if this does turn out to be UI on a chip, as in user interface on chip, then attaching it to the neural or the neocortex or your brain in general has all of these security slash other considerations. I even thought about the fact that if you can activate it and reactivate it as you need it with some other modular security provisions in place, and that could be another mechanism. So I don't exactly know what the eventual development will look like. Maybe it's just the fact that you stand in certain locations, and those certain locations have the ability to be able to pick up your brain waves when, again, you are standing there, and that could just be a way. But I don't think those kind of things will matter 15, 20 years from now, when computing is going to be dirt cheap, and that kind of reality would pretty much exist anywhere. So, again, there's a lot of benefits. The example I shared is just a start. It's going to start there. It could evolve to different ways. Again, go back to Douglas Engelbart, kind of look at it as the mother of all demos. And, if you focus, then those are largely the designs we've been with since that time. It's like, not only were they invoking the UI using mouse and keyboards, but they were doing like things like teleconferencing and remote desktop and whatnot. So it was pretty powerful at that time, even, or live collaboration at that. So it's time for something else, and by intuitively, redesigning the mechanisms through which we interact with the UI, we could start taking steps in order to be able to kind of bring about that computing at the speed of thought that has always been the promise. And another way I was thinking is, I was actually thinking of two ideas, and I wasn't thinking of merging them at that time. It was kind of thought of one and the other. I don't know how my brain actually works, but what I was thinking was, so there's something called material design. It's part of Google's offering. It's been in the works for a couple of years now, and starting to come out in their kind of framework for app development. And what I was thinking was, what if instead of like each constituent piece within the UI being intelligently, I don't know how to explain material design. The people who made it can't, like, they just show the demo. It's difficult to explain, but instead of like each, like if this is the real state for a user interface through which we are interacting with some construct, but instead of like constituent pieces within each one of those domains, what if you went more granular? And if you did that, then you could build stuff that much more intelligently. And so there's technologies that we could leverage in order to be able to, again, look at specific markers, and that would allow us to be able to control the UI that much more intelligently and efficiently and in a smarter way. I gotta think about this idea a bit more. But it's probably gonna be a private video. But this is my idea for how we should start thinking about user interfaces that are sentient, and that's going to allow us to start taking computing to the next level. So this is not about if you have the smartphone and you're about to press the button, then it senses that's where you're going to press, and then it just does the actual action without you actually pressing on it. It's like in that construct, the sensor is monitoring your presence around a very far, like tiny area, right? Or not tiny, but like a specific part of the real estate. So if this is the total real estate, it's sensing I don't know how it does it, but the thing senses the field being disturbed or something, and then it just does whatever that actual part, whatever the application has been designed for, that's supposed to do. But what I'm thinking is that the thing is not even there. It's a direct coupling from the mind or the brain to the computing device, and we just interact through those mechanisms. This is not virtual reality. This is not augmented reality. This is the direct coupling of your brain with the computation, with the computational device, and you're going from there. So something to think about, and I'll end the video at this point.